Okay, so we'll do about 40 minutes here of discussion about the app runtime. Feel free, if you have any questions while I'm talking, to post them in Slack on let's see which channel is best for that. Perhaps on the general channel is probably fine for that. Just to bring up any questions that you have as I'm speaking. If there's anything that I don't cover that you would like covered as well, please feel free to post it there and I can address it later on in the day as we get into some of the breakout sessions. We will be having a short quiz at the end of this session. There are just 2 questions, pretty straightforward. You can also resubmit that as many times as you want, I believe, and you can work on that with the group in the breakout session as well if you want to wait till after the break to take a look at that. But that will be based on basically how to use app runtime and how it works in functional React components using the use data query hook. We're going to focus mostly on use data query here today, which is for reading data rather than for writing data. I'll cover a little bit of review about what data queries are and what data mutations are as well. Most of the advanced features that I'll cover also apply to data mutations, but I'm going to use queries as the example here today. So with that, I'm going to go ahead and get started. So just a little bit of review. We have a library called app runtime, which is included out of the box in the app platform if you implement a new application that way. And it provides a few different things. The one that's here on the screen right now is talking about the app runtime provider. Actually, the title is wrong here. Apologize for that. In most cases, if you're using the app platform for your application, you do not need to include an app runtime provider. That allows you to specify a base URL and an API version for all of the queries in your application, or specifically underneath this component in your application tree. And you can use that if you're building an application that is not using the application platform. We recommend, obviously, that you do use the application platform because it makes a lot of things easier and it helps us to push things forward. But if you're not using that, you can use the provider to specify those same configuration parameters that are provided out of the box by the application platform. This is also, as I think Michaela mentioned, if you were to use a second application app runtime provider, you could use that potentially to contact a different DHIS2 instance for certain data queries. That's a very advanced use case that isn't super well supported, but it is possible using a custom app runtime provider. I'm not going to get into that too much. Generally speaking, we talk about 2 different things when we're talking about app runtime and the data engine or using data in DHIS2 applications. The first is queries and the second is mutations. In general, queries are for reading and mutations are for writing. You can think of them also as they're analogous to some HTTP verbs under the hood. So queries use a GET request for REST API, and mutations use basically all the other request types. So put, patch, put and patch and oh man, why am I blanking? Post and delete requests across the network, if you're familiar with REST API terminology. You don't need to know what's actually going on under the hood of data queries and data mutations. That's kind of the whole point. And the idea is that if you use these, we're able to, behind the scenes, seamlessly do things like cache data locally in your browser so that you don't need to actually create a HTTP request if the data already exists, and those types of things in the future. Today, they do translate directly into HTTP requests. The other piece of the DHIS2 app runtime that is not covered very often, or not very well known maybe, but can be very useful actually, is allows you to access those variables that you set in the provider or that are set for you by the app platform. And those two variables are the base URL and the API version for now. There might be other, or there will be additional configuration variables that are passed throughout your application using the useConfig hook in the future. But for today, it is base URL and API version. And this lets you anywhere in your application, without passing a lot of props through all of your different components, to be able to access the URL of the DHIS2 instance that you're talking to if you need to use that for something that isn't fetching data, for instance. It also lets you do things with the API version if you wanted to use that. A lot of times you won't need to use this, but it can be very handy if you need to pass the base URL to some other component or some other feature, functionality or library that isn't aware of the app runtime. But getting back to queries and mutations, as I mentioned, queries are for reading. And in order to read data from a functional React component in a DHIS2 application, we have a hook called useDataQuery. This useDataQuery allows you to declaratively define data dependencies and respond to loading error and data state changes. What that means in practice is that you write this one line down here, down at the bottom, and then it will basically re-render your component every time the state of that request changes. So if the network request is in progress, it'll tell you that you're in a loading state. If an error has occurred, it'll tell you you're in an error state. If you're finished loading and no error occurred, then you'll get the data that was the result of that API request back to your component. And I'll go into that a little bit more and how to deal with loading error and data states, loading error and completed states in a minute. This is the useDataQuery hook again, which is used for reading data from the API. And here's an example of a simple data query. You can use the playground runtime.dhis2.nu, which is where our app runtime documentation is hosted. You can also find that linked from developers.dhis2.org. In this playground, it is a DHIS2 application built with the app platform, and it allows you to basically to experiment and test out different queries and mutations and see how the real world results of using those against a DHIS2 instance. I will note that you'll need to add runtime.dhis2.nu to your cores whitelist in your DHIS2 instance if you want to use this against your own DHIS2 instance. You can also, however, install this application from the app management app in that instance. But if you're using this against a, like for instance, debug.dhis2.org instance, make sure that the runtime.dhis2.nu is in the cores whitelist, and also make sure that you've read the post about cross-site, cross-origin cookies and what that means for your browser and for your DHIS2 applications, because you will need to disable that feature in Chrome, for instance, in order to have an application be able to talk across different URLs. Just pointing that out, the easiest way to do this is to install the application from the App Hub in the App Management app in your DHIS2 instance. But here's an example of one simple data query. So this is using the resource me, which is just /API/me if you're using a regular API request. And we're passing just a single parameter, which says that the field we care about is the name field. So normally if you just do /API/me, you'll get a whole ton of different fields about the currently logged in user. We logged in to this playground instance, playground to a different DHIS2 instance with a specific user. And in this case, we're requesting just the name field for that user. So we specify the parameter of field with name, Click execute, and the result, as you can see here, you have the name of the object that you're requesting. We said me on the left here, and it's me on the right. And then we're just getting the single field of name. It's a very simple data query. However, it can get more complicated because, as you saw, we had named that particular request for the me resource. So here again, we have a me resource, but in this case, we have 2 different parameters, name and email, and we also have 2 more resources that we're requesting in parallel. So a query can have multiple items within it. So in this case, we're requesting the me resource, the indicators resource, and the data elements resource, all within the same request. So the advantage of this is that we're actually spawning 3 different HTTP requests across the network, but they all start at the same time, and we don't render the result until all 3 have completed. So if you were to do this yourself, there'd be a fair amount of coordination involved to basically spin off all of the HTTP requests, wait on a bunch of promises, handle errors in any one of those responses, and make sure you don't actually render the results until all 3 have completed. That's done automatically for you with the app runtime. And in this case, you can see on the right here that we have 3 different sub items or sub objects in this JSON object: the me object, the indicators object, and the data elements object. And each of those has the result of that particular API request that we've specified here on the left. In the indicators case, we're using a collection resource. So indicators is the list of all indicators in the DHIS2 instance. We're selecting a page size of 2, so only 2 items from the indicator list. We're going to select the 3rd page, and we're going to select a few different fields. For the data elements case, we are selecting just an individual ID. So this is one specific data element, and it also has 3 params fields that we selected. The 3rd of which is actually 2 fields that are part of a sub item of this data element. If you remember the session that Lars gave at the end of last workshop, talking about how you can expand basically sub properties of or related resources from a resource in the DHIS2 API, you can do that very easily here in the data query. And the result that you get on the right here is that you get the indicators list and the data element, a single data element. Indicators list also has some pagination information. So it tells you that you're on page 3, that there's a total of 39 pages. Total number of indicators is 77, and that our page size is 2. You can use that then to request the next or previous pages later on. Go ahead and go to the next one. I see that I might have a question coming in. Yes, that's a good point. Pete just mentioned that it's possible to have multiple filters, for instance. Similarly, you can also have multiple fields, as we saw here in this. As we saw here. So in a param, you can have a single string or number value. For instance, here we have page size of 2 as a param. But you can also have an array, and the app runtime will do the right thing. So it actually expands them differently into the URLs of the API for fields and filters. But if you have filters here with recent versions of the app runtime and you have an array, it will actually expand that into multiple filter parameters that it will pass to the API. It's a lot easier than trying to basically spell out a long API string with multiple filter parameters. You just say filter, and then you have an array with multiple entries in it. Thanks for that question, Pete. Getting on to mutations. So as I mentioned earlier, queries are for reading, mutations are for writing. You can declaratively define mutations, which means that you're telling basically the app runtime what you want to happen, not how you want it to happen. It's similar to what we just did with use data query, but there's an additional parameter that's returned. So it actually returns an array. The first one is a function that you can call to actually execute this mutation that's called mutate. You can name it whatever you want, but it's the first item in this returned array. And then you have 3 or 4 objects, or four parameters of an object, which are similar to in the use data query case. We have loading, error data, and a called state. And I'll get into what that does in a minute, because that's the same as doing a use data query with the lazy parameter. You pass the mutation, which I'll get into in just a moment, and some options to that hook. There are a few different types of mutations. As I mentioned, under the hood, this is translating to a request to the DHIS2 API. So if you use a create mutation, you're going to create a post request. If you use an update mutation, you create a put request. You can also create a partial update mutation, which is a patch request, and then a delete mutation, which will remove an object. So generally, if you're creating something new, you use a create mutation. If you're changing something that already exists, use an update mutation. Use a partial update mutation when you're only changing a part of something that already exists. So if you're changing only the name of a user, for instance, you should use a partial update rather than a full update, because if you use a full update, you need to pass all of the parameters of that user or all the fields of that user rather than just the name. I won't get into that too much. You can experiment and see how that works. It's also important to read the documentation of the API to make sure that the endpoint that you're talking to supports the patch or put requests for a particular endpoint. Delete mutation does what it says. It deletes the object that you pointed at. Here's an example of a mutation. So in this case, we're going to create a new indicator. So we specify the resource is indicator, or indicators. The type is a create mutation. And then we pass it some data, which is what is used to actually create that indicator. We have the name of the indicator, short name. We specify an indicator type, which actually references the ID of another item in the DHIS2 data model. And then we have 2 other things, numerator and denominator, specific to indicators, which are basically specifying how this indicator is calculated from raw data. We pass this create mutation. If you're in the data playground again, you can switch from query to mutation and click execute, and it will give you a response that says whether or not that was successfully created. You can then use this in your application to give the user feedback on how they should change something. If they, for instance, are missing a field, or they mistyped a field or something, it should be returned as an error from the server that you can then display to the user. One question from Sergio here. Maybe you can cover later, but can use data query and use data vacation be used to interact with the data store? That will be covered later. That will be covered tomorrow. The short answer is yes. You can absolutely use data query and use data mutation to interact with the data store. You can use them. You can use this to interact with any API resource in the DHIS2 API. So anything that shows up in the documentation for the web API, you should be able to use a query or mutation to access. For the data store specifically, we'll cover, Hendrik, my colleague, will cover that a little bit more tomorrow. We also have an early release of a library specifically for doing persistence in the data store for DHIS2 applications. So that allows you to save, load, and basically persist information, whether that's settings or saved objects or that sort of thing, both to the user data store and to the regular data store, and to propagate changes to those objects across your applications. It does all of that for you. We're using that in a couple applications, not too many at this point, but it is available. It's called the App Service Data Store. I believe we'll cover that briefly tomorrow as well. So that is a mutation. Cool. Let's see where we go to the next one. Yeah. Okay, so now that was all review. We're going to get now into some new content. Before we do that, I think actually I'll do this first section and then we'll take a quick few-minute break since it's kind of a lot of information to digest. So we'll take a few-minute break after this first new content about handling loading and error states. So as I mentioned, when you use a use data query, you get a few things back in the object that's returned by that hook. One is a loading variable, one is an error variable, and one is a data variable. For those of you that aren't that familiar with React and specifically with functional components or hooks in React, this can be a little bit confusing because it looks like you'll only ever get one answer from this function. The difference is that React will actually call this whole function multiple times. So the hook, the use data query hook, can actually tell React to call your function again with different responses to that hook. I'll go through how that exactly works, but basically this means that every time this function is called, it will have a specific value for loading, error, and data, but it might be called multiple times. So the first time it's called, it's going to have loading set to true because it's loading a new value across the network. Second time it's called, it might either have an error or return the actual data to the data variable. And I'll show you how that works here. This is general React stuff, but it's important to know when you're using a hook like use data query to access data in a React functional component. So the first render or on mount of this component, what actually happens? So the first time through, we send off our query across the network, which means we're making an HTTP request to the DHIS2 instance. And the result is that we've started that query, that request, but we haven't gotten a response yet. So we don't know if it's an error. We don't know if it's successful. We don't know what the result is. That means the first time this function is called, it's called with loading equals true. Loading is a Boolean variable. We have an undefined error and undefined data. This means that the first if condition here is triggered because loading is true. So we say if loading is true, we're going to return the string loading with ... ellipses. This means that the rest of this function, the if error and the final return, are not called on this first render of this function. The second time this function is called, so this means we call this function once to render a component, which means that we're actually drawing the string loading into the application somewhere. Then we've said that we've started this HTTP request across the network that might take 100 milliseconds, for instance, or maybe even takes a full second to go across the network, find the server, come back, and then you know at that point whether there's an error or you have a success and have some result to display. So the second render, you have two options. The first is if an error occurred. On the second render, this whole function is called again, and the values of those variables change. So loading is false, error is the name of, or the string of whatever that error is. It would actually probably be an error object in this case. And data would be undefined still because we had an error that occurred. The other option would be if an error does not occur and the data actually loaded, we call this function the second time with a different set of variables. Loading is false, error is undefined because nothing happened, or no problems occurred. And then data is the result of that API request across the network. So in this case, the first two conditions, if loading and if error, are both evaluate to false, and so we don't return anything for those two statements. And then at the end, we return hello plus the name that is returned from this query across the network. This is just a kind of a general overview of how hooks and React functional components work, specifically with use data query. And it helps you to see that you'll actually get 3 different renders or 3 different versions of the same component or piece of your application. by rendering this or by using this component. The first time you can get a loading state. The second time you either get an error state or a success state. And there are some more states that we'll get into in a minute. Yeah, we'll get into refetching, which allows you to go through more states as well after a short break. So I'm gonna let us take maybe 4 minutes break. So in 11:40, we'll come back and continue here. But in the meantime, feel free to ask any questions you have. Get up, get a glass of water or something like that. Let this sort of digest. Ask any questions you have on the general. Thank you to everyone who's asked questions so far. And we'll be back in just a few minutes.